here we go. We're kind of at the end. So this is the last sort of kind of video in this series of factoring polynomials, and it's factoring polynomials with non-real or irrational zeros. Every single one that we did in 4.3, I think it was, you always ended up with this quadratic that could factor. And all that's going to happen today different is that when you get to your quadratic, you're going to have to figure out what the other zeros are and then potentially write them as a product of linear factors. So here's what the questions will read. For each polynomial function, find the rational zeros, because that's always what you're going to find first. Then the other zeros, that is solve f of x is equal to 0, and you're probably going to be using the quadratic formula. There's not many people who, opt to do completing the square, although it is always an option. But I would say quadratic formula or completing the square. B square, or potentially you could use that square root method or solve algebraically if there is no x term. So it's going to be one of these three. So when factoring fails, you're left with these other three methods of solving a quadratic function. All right, let's do it. So thinking back to 4.3, when you're factoring a cubic function, now something that I didn't mention there is that you could potentially check to see if this will, what's the word? Factor by grouping. So if I look at this one, I should almost do it on a separate piece of paper. Maybe don't write this. I just want to show you that I think this one you can. So if I take out an x squared, I'm left with x minus 1. And if I take a negative 3, I'm left with x minus 1. And then I'm left with an x minus 1 comes out, and I'm left with x squared minus 3. Maybe you should write it. Maybe that's okay. I just was feeling like we should practice that whole step 1, step 2 thing again, but this is fine. So if you look at a 4-term polynomial and you notice that it can factor by grouping, you go for it. This is the same as using that synthetic division to factor a polynomial. All we're doing is building up these tools in your toolkit that you're supposed to know when you can and cannot use. So yeah, let's do this. Let's do it as factoring by grouping. If you feel like you want to practice the step 1, step 2 thing, what's going to happen is when you plug in 1, you'll see that this gives you a remainder of 0. Actually, let's just do that on the side. Here you go. I'm going to tell you that 1 works. I'm not going to test it. I just know it works because it just worked here. So I'm going to use synthetic division and go 1, negative 1, negative 3, and 3. And so I'm going to bring down, I'm going to multiply, I'm going to add. I'm going to multiply, I'm going to add. I'm going to multiply, I'm going to add, and I get that remainder of 0. And look, this is going to be x squared, this is x, this is constant. I'm left with x squared minus 3. Awesome. Okay, but the thing is, now we're left with this x squared minus 3, which theoretically doesn't factor. Maybe you remember that I mentioned in an earlier lesson, you can treat this like a difference of squares. This could be x minus root 3, x plus root 3. Maybe. Or maybe you're like, ooh, how do I solve that? Well, I'm going to say, what would make x squared minus 3 equal to 0? You can use quadratic formula. You can't complete the square with this one because it doesn't have that middle term, but we could use the square root method. You could say, hey, when x squared equals 3, when x equals plus or minus the square root of 3, those are my zeros. The whole point of this is that it's going to factor to x minus 1, and then x minus root 3, x plus root 3. So there we just did 2 methods. 1, recognize it as a difference of squares. 2, solve it using the square root method. 3, quadratic formula. This one has a b of 0. So this has a equals 1, b is 0, c is negative 3. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Which is going to leave us with plus or minus the square root of, that's hard to read it as a 4, but negative 4 times negative 3 is 12, all over 2. Oh, gross. So this will give me plus or minus root 4, root 3, all over 2. Now the square root of 4 is 2, so I'm just going to cross those out, and I get plus or minus root 3. So I just showed you 3 methods of factoring this into linear factors. Method 1, kind of a difference of squares. Method 2, square root method to find the zeros of the quadratic function and then put them in as a product of linear factors. Or quadratic formula. if you love the quadratic formula. Okay, let's do the next one. So this next one, the original function does not factor by grouping. So we're going to have to do the step 1, step 2 thing. So step 1. Step 1, we have to find a factor of this polynomial. So we're going to choose things like plus or minus 1, 2, or 4. What should we try? Well, I'm not going to try 1 because I can see right away that 2 and a 1 is never going to make 4. So let's try a 2. Let's try I'm thinking a negative 2. Right, because that'll make this positive, but this will be negative. Let's try that. So negative 2 cubed minus 2 times negative 2 plus 4, which is going to give me, I lost my calculator, that's going to give me negative 8 plus 4 plus 4. Yay! 0. So now I'm going to take that little negative 2 and put it in its box. I'm going to pull off my coefficients. Notice that I'm missing the 0x squared term. So I'm going to go 1, 0, negative 2, 4. And then I'm going to pull down. So I've got a 1, I've got a negative 2, I've got a 4. It adds to give me 2. I'm going to multiply, and I'm going to add. I feel like I'm mumbling. I don't know what you guys do when I'm doing that part of the video. I apologize. Okay, so what did we just do? Well, we just factored my cubic function, I'm trying to decide where to write this, as x minus minus 2. So if my 0 is negative 2, my factor is x plus 2. And then I've got x squared minus 2x plus 2. Normally, we would be able to factor this, right? But two numbers that multiply to give me 2 and negative 2 add to give me negative 2 don't exist. Sorry, I forgot step 2. So we have to do something else. Well, we're going to solve the quadratic. We're going to say, what makes x squared minus 2x plus 2 equal to 0? Well, we could factor. Nope. We could square root method. Sure, you want to do it. Or you could use the quadratic formula. You can't use square root method because of the x term. I find most people jump right to the quadratic formula, so I'll jump right to the quadratic formula, but I'm really wanting to complete the square with this one because this is an even middle term, but whatever. So we're going to go negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is going to give me 2 plus or minus the square root of 4 minus 8 all over 2, which is going to give me 2 plus or minus the square root of negative 4 all over 2. And now I need to simplify this. Oh, I ran out of room. Okay, that's going to give me 2 plus or minus. Now the square root of 4 is 2, and I'm left with square root negative 1, which is an I, all over 2. Then I can take the 2 out of everything, so I'm allowed to do it. So remember, you can factor a 2 out of the top, and then the 2's are simplifying, or you can see that both terms divide by 2, and I get 1 plus or minus I. Okay, so there's a few things I didn't show my work there, right? Square root of negative 4. What is wrong with my 4's? Is equal to the square root of 4 times the square root of negative I, which is how we get 2I, or square root of negative 1. Okay, now what? Well, now we know our zeros, which is what we would factor this into. So we'd have x plus 2, and then we'd have x minus 1 minus I, and x minus 1 plus I. Again, if you're lost on that, you have two choices. You've got x minus 1 plus I, and x minus 1 minus I. Or you can think of x equals and then bring everything over and make it the opposite sign. So if x equals 1 plus I, you'd end up with x minus 1 minus I, right? If you have x equals 1 minus I, you end up with x minus 1 plus I. So either multiplying the negative through or bringing everything to the other side changes all of their signs. And then double checking we answered the question. So the question said, for each polynomial function, find the rational zeros and then the other zeros. That is, solve f of x is equal to 0 and then factor into linear factors. So this is my linear factors, and then maybe I should declare my zeros. My zeros were -2 and 1 plus or minus I. So these are my zeros. This is my product of linear factors. We should do the same thing up here as well. This is my product of linear factors. My zeros were 1 and plus or minus root 3. Whoo-wee. All right, I think we have one more example, don't we? Yeah. So if you're feeling good, give this one a try. If you're not feeling good, then just keep watching. So for this one, the first thing I have to do, step 1, is find my 0. So I'm going to try plus or minus 1 or 2, keeping in mind that I could also use plus or minus divided by 3. So I'm hoping 1 or 2 will work, but I could also use plus or minus 1, 2, 1/3, and 2/3. So if these fail, you're moving on to these fractions, which we're hoping not to, but it could happen. So, and I will try not to do that to you on a test. What should we put in? Well, if we put in a 1, oh, I don't think it's going to work because we're going to have 3 plus 8. Let's try it. So I end up with 3 minus 7 plus 8 minus 2. That's minus 9 plus 11. Okay, not 0. But I feel like the plus 1 was the key. I think if I go -1, I think it's going to get too big. So let's try 2. So I'm going to have 3. Oops, that's not a 3, that's a 2. 3 times 2 cubed, which is 8. Minus 7 times 2 squared, which is 4, plus 8 times 2 minus 2. I don't know. 24 minus 28 plus 16 minus 2. Oh, nope. Well, let's try -2. Maybe it's going to work. I feel like you're all sitting there that -1 would have worked. I didn't even try -1. Should I try -1? Let's try -1. Before I get too far into this, just go in order, because it might. So this would be 3 times -1 minus 7 times +1 plus 8 times -1 minus 2, because sometimes I just miss the obvious. -3 minus 7 minus 8, no. Okay. I was like, maybe. Okay, no. No. So let's try negative. Oh, I don't think -2 is going to work. Oh no, did I assign a fraction one? I redid these notes recently, so usually I have the notes all memorized and I kind of know what to expect, but this is like just as much fun for me as it is for you. Okay, so we're trying -2. Oh, is this going to work? So 3 times -8 minus 7 times 4 minus 16 minus 2. Definitely not. Okay, the negatives definitely don't work, so it's got to be a positive. Okay, so I must have done this one on purpose. So this must be one of the ones where the fractions was an option because I wanted to show you what happens. I thought I was just going to avoid these altogether. Let's try 1/3. All right, we've got 3 times 1/3 cubed minus 7 times 1/3 squared plus 8 times 1/3 minus 2. Gross. Okay, so let's write this as 3 times 1 divided by 27 minus 7 times 1 divided by 9 plus 8 divided by 3 minus 2. Ah, there it is. Yay, finally. Okay, so I must have been in a really like, let's prove it to you mode. Now, here's what I'm going to show you. We're going to do this the way that we've done every question. So we're going to move on to step 2. In step 2, we're going to take this 0 of 1/3 and we're going to put it in the box. Boom. We're going to pull off our coefficients in descending orders of power. So we've got a 3, a -7, an 8, and a -2. And we're going to start going. So we're going to pull down. We get 3. Oh, nice. 1/3 of 3 is 1. And then we get to add, which gives us -6. Oh, that's nice. 1/3 of -6 is -2. 8 plus -2 is 6. 1/3 of 6 is 2. That reaffirms that my remainder is 0. Now, What I want to show you is that if you're using synthetic division, you have to do kind of a little bit different than what we were doing before, in that we're going to put x minus a third in as my 0, and I'm going to explain why. It's because synthetic division is a bit of like it's a cheat, right? It's not long division. So if I do x minus a third, I'm going to have 3x squared minus 6x plus 6. Now looking at this, what did I tell you was going to happen? I told you that if you end up with an x minus a third, there's going to be a 3 that's going to come out to get rid of it. So if you look at this second bracket, I hope you see the greatest common factor of 3. So I'm going to put that 3 out front. I've got x minus a third, and I'm left with x squared minus 2x plus 2. And if I multiply that 3 back in, I end up with 3x minus 1. So yes, it always ends up as 3x minus 1. It never gets written as x minus a third. And because if you use synthetic division, it's a bit of a cheat. It means that all of these will get multiplied by 3 so that I greatest common factor out the 3 and it comes back through. If you had done long division, now I don't know how long you want this video to be, but if you had done long division, you would have actually used the factor, right? You would have used 3x minus 1 to go in to the entire function, which I don't remember what it was, but 3x cubed minus 7x squared plus 8x minus 2. And maybe this is like a nice little review, right? So if I did long division, first term divided by first term, all of you are like, I just trust you. Do you have to show this? We'll just fast forward. So I'm going to get x squared. It's also a nice review of long division. So we've got x squared times 3x minus 1, which is going to give me 3x cubed minus 3x squared. And then we subtract. Remember, long division, subtract. Gone. I'm left with negative 4x squared. Bring it on down and bring it on back. The number that's going to multiply by this, oh, it's going to be gross. I'm regretting my decision. All this just to prove to you that it's going to happen. Did I make an oopsie? Phew, I had to pause the video there for a second. I'm like, I think I made a mistake. Were you all screaming at the screen? Because it won't end up like that. You never end up with fractions. I was like, something's gone on. Okay, so sorry. X squared times negative 1 is negative x squared. It's always good to have like catches of your mistakes. If you're kind of aware of what's happening, you'll catch a mistake before it takes it too far. So negative 7 plus 1, which give you negative 6x squared. Then you're going to bring on down that plus 8x. And then we've got negative 6x squared divided by 3x, which is negative 2x, multiplied by 3x minus 1. Gives you negative 6x squared plus 2x, and then we subtract to get 6x, and then we bring it on down. 6x divided by 3x is giving you 2, times it by 3x minus 1 gives you 6x minus 2. Yay, remainder of 0. And I got excited and stopped remembering to write my quotient, right? So it's minus 2x, and then it's plus 2. So using long division, I got to this answer here. Synthetic division is a bit of a cheat because we have to put the 0 in here instead of the factor. Everything gets tripled, and so you'll just always greatest common factor out and it'll work. This isn't going to happen a lot. I wanted to throw it in the notes in case you came across a question in your homework where this happens, but just know this is what it is. Okay, synthetic division is awesome, but it's got a drawback. Does that drawback really matter? No, I can recover for it, but I just want you to know that the factor will always be 3x minus 1. But using synthetic division, you'll put in x minus third, and it'll become 3x minus 1. If you did it the way it's supposed to be done using long division, none of that would happen. You'd go straight to 3x minus 1, and then you'd get this nice polynomial quadratic. Okay, anyway, the whole point of this now is that we've taken it down to 3x minus 1, and x squared minus 2x plus 2. I can't factor x squared minus 2x plus 2, and so I have to either quadratic formula, square root method, or complete the square. Didn't we just do x squared minus 2x plus 2? We did. That is hilarious. I was like, this is feeling very familiar. So choose your poison. Maybe don't look on the question above. Let's do it this time using square root or completing the square. Don't you guys love me? I know you probably hate me. Okay, so I'm going to solve this one using completing the square. So I'm going to go x squared minus 2x. Half the middle term squared is plus 1. Add it and subtract it. This is my perfect square trinomial. It goes to x minus 1 all squared plus 1 is equal to 0. I end up with x minus 1 all squared is equal to negative 1. I get x minus 1 equals plus or minus the square root of negative 1. So I get x minus 1 is equal to plus or minus I, and I get x equals 1 plus or minus I. Isn't that nicer than the quadratic formula? I did quadratic formula because that's what most people will do, but completing the square is pretty awesome. And so then the moral of the story is that as a product of linear factors, I'm going to have 3x minus 1, and I'm going to have that x minus 1 minus I, x minus 1 plus I, and my zeros are a third, and then 1 plus or minus I. Whew, maybe someday I'm going to get annoyed and change it, but I really don't want to re-record this video. So funny, they both end up as x squared minus 2x plus 2. But whatever, at least I showed you two different methods of then going from there. Good luck!